Doing section 3-4 notes today. Today's notes are called Using the Quadratic Formula. On the front, it has taking ax squared plus bx plus c equals 0, which is in standard form. And then it has all the steps for completing the square, but you don't know any of these numbers. So it's a little bit challenging at our level to truly understand this. And we were going to do justifications, but what we're going to do instead is we're going to move on because of time. It's not a proof. I mean, it's kind of that. Like, I can show you the first justification. How do I get, I'm doing one of them, stop. How do I get from ax squared plus bx plus c equals 0 to ax squared plus px? Okay, so if I subtract something from both sides, what property allows me to do that? Subtraction property of equality. She's in geometry, and we just did that, yeah. So that's what the justifications were going to be, but I'm not going to do that right now. But basically, I mean, like you see the whole b divided by 2 square thing, you see that happening, and then you see solving it where you have to square root and put plus minus in there. And then eventually, all the way down, they combine, add fractions together, and this right here, the result is called the quadratic formula. So what this is doing is saying, if you do complete the square, we can simplify it by doing all of complete the square with a formula. So this is complete the square, just in a shortcut formula. And you're so lucky today, too, because this formula has a song. So we are going to sing it. And if you don't want to sing it, you can have a solo. If you don't want to do it as a group, you can do a solo. So I will, oh, he wants a solo? You want a solo? He wants a solo. Well, Drake wants a solo. All right, you guys, the song goes to Pop Goes the Weasel. Do you know Pop Goes the Weasel? Do you know that? No? Do you know Pop Goes the Weasel? Yeah? Maybe? Do you know Pop Goes the Weasel, Simrat? Okay. Daniel, do you know Pop Goes the Weasel? Okay, we're about to sing it. Now, I'm going to sing it for you first. So I'm going to... No, I'm not going to go on your own beat. Okay, we are learning right now. That's not how Pop Goes the Weasel goes. Oh yeah, there is another song. But it's not that Pop Goes the Weasel song. There is another song. It's not that one. Okay, ready? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Let's do it. You can totally record something for me.
Hey, look, I make music.
That's what I'm saying. But you got to put yourself like doing the song on top of it.
No, you need to make it a remix.
Okay, here we go.
Don't talk to me.
Together, unless you want a solo, together. Okay? Those of you that don't know Pop Goes the Weasel because that was not sung in the country that you are from, you just catch on. Okay? It's a fun song. Ready? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Thank you for singing. I could hear you. So we're going to do it one more time. There's actual science that says you learn something better, you memorize it better, and it sticks with you more if it is put to song. Yeah. You ready? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Good job. All right, now, where would I use this? This is instead of doing what?
A
Oh,
squared,
this
AX
one.
squared plus
Oh, that
BX.
works? Oh, it's fucking with the square.
Okay, so we know how to complete this square. This is completing the square, and solving by square roots is just going to be in a faster way. Now, that doesn't mean you never get to learn complete the square, because we now have an alternate way. If you go on past this course, you will have to use complete the square for something else. So this is the quadratic formula. We just sang it a few times. Now we're going to solve this using the quadratic formula. One thing that I didn't say, but I'm going to say right now, is in order to use the quadratic formula, it has to say equals 0. So if the equation does not say equals 0, like example 1 does not say equals 0, we have to make it say equals 0. It also has to be in the order of the x squared term first, the bx in the middle, and the c, the constant by itself at the end there. So is this in the correct form? No, we have to make it say equals 0. What do I do?
Oh, crap.
So we have x squared plus 3x minus 5 equals 0. Then we sing our song. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Okay, or like on a quiz or a test, you don't actually sing it for every single question. You just sing it to write down the formula, and then you can just like plug stuff in. All right, now we're going to simplify it. So I have next negative 3 plus or minus. That's going to give me 9 plus 20 all over 2. So I've got negative 3 plus or minus square root of 29 all over 2. There are 3 questions we have to answer before we can move on. There are 3 questions we have to answer before we can move on. Oh, looks like you got that back. That's good.
Yeah. Was it you?
Me, I sent it to him. Thanks, Mrs. Criswell, for giving my phone back to me.
Oh, yeah. Thank you.
Mm-hmm.
Yeah, no. Don't go up.
Hey, now you have to write thank you card.
Okay. There's 3 things we need to check before we know we're done. The first thing is the radical or the square root, is the square root simplified?
No, wait, yes.
That's the first question. So we look at square root 29. Can we break that down any further?
Nope.
We cannot. Second question. Can a number... Oh, that's not my second question. That's my third question.
Okay, let's just read that question and then flip it.
I know. I mean, I'm going to come to that anyway. Okay, can a number factor out of the numerator and denominator to cancel? What?
Just kind of off topic, but during those times with A's, did you go all the way to Indianapolis or like
No.
right?
No.
Okay.
So what I'm asking, is there a factor of negative 3 and square root 29? Which the answer is no already,
No.
because these have nothing in common. And the same factor of 2, and the answer is no. So there isn't anything to cancel. And then my third thing is the denominator positive?
Yeah, that's, well, no.
Yeah, it is.
Denominator?
Denominator's the bottom.
Yeah.
Yeah, so we're good. We answered yes to all of these. No, we didn't. We answered no to number.
Said yes to just 3.
Hold on. Is the square root simplified? Yes. Can a number factor? No. These really aren't yes. I mean, like, these are just reminding you of what you need to do. Is the denominator positive? Yes, it should be. So we need to have a yes for this one. Here, I'll write yeses and no's. We need to have a yes for the square root being simplified. We need to have a yes for the denominator being positive, and then if we're done, then we would have a no for question 2. But I'll show you what happens if the answer is yes for question 2, or if the answer is no for any of the others. Okay. All right. So let's do x squared minus 6x plus 4. Is it equal to 0? Good. Let's do it. X equals. Okay, I can't do that fast. Opposite b plus or minus square root 36 minus 4. 1 times 4. All over 2 times 1. So then I've got x equals 6 plus or minus 36 minus 16 is 20 over 2. That was a little bit fast.
Is that 36 or 30?
36. That was a little fast, but like, you guys can do your math at your own rate when you try this on your own. I'm going to show you the new stuff. So we need to go through our questions. The first question, if the square root can be simplified or not. Like, we need to simplify it. Can it be simplified?
With the square root?
Yeah, the square root of 20. It can be simplified, right? Okay. So if I simplify that 20 to square root 4 and square root 5, we now have 6 plus or minus 2 square root 5 over 2. My next step, would I be able to factor out a number from the numerator and the denominator? Is there a number that we could take out, a greatest common factor that we could take out of the 6 and the 2? You can't take 3 out of a 2. But can you take 2 out of the 6? Can we also take a 2 out of the bottom?
Yeah, if it's only 0.
No, it's not. So we're going to rewrite this. So I have, I'm taking out a 2, and I have left over 3 plus or minus radical 5. On the bottom, I'm taking out a 2, and I have left over times 1. So I factored it out. GCF factored it out. If you can factor those out, now I can cancel them. And then my last question, is the denominator positive? Because it needs to be positive. Is it positive? Okay, so we're good there. So then our answers are x equals 3 plus or minus radical 5. Okay, these are pretty much the exact same thing. I'm going to go to example 2, okay? I'm skipping the student practice 3 and 4. Example 2, what should we do first? Right, are they in that form with the order and it equals 0? Are they there yet?
12x and add 4 to both sides.
Okay, subtract 12x, add 4. So I'm going to have 25x squared minus 20x plus...
No? Wait. No, it is. Yes, sorry.
It's okay. I was double guessing myself too, or what's it called? Second guessing myself. All right, so this is what I have. And this says to solve it using a quadratic formula. So we will do x equals opposite b plus or minus square root b squared minus 4 times 25 times 4. All over, that was a horrible line. All over 2 times 25. All right, simplify. I get x equals 20 plus or minus square root. Let's see, 400 minus 100 times 400 minus 400. Who was that? So my next step would say x equals 20 plus or minus square root of 0 over 50. What is the square root of 0? Anybody know? It is 0. 0 times 0 is 0. No, you can't divide by 0. So now I have 20 over 50. I drop the plus or minus because if I add 0 or I subtract 0, it's still 25. Or 20, sorry, 20. Does this reduce?
Yeah, 2 over 5.
So what happened because we had a 0 underneath the radical? What happened to this one that was different than the first two that we did? How was this one different than the first two we did? What did you say? We didn't have the plus or minus, and what's no plus or minus tell us? Max, what were you going to say? Were you saying something? Oh, that was Martin. All right, somebody over here.
We don't, like, since it's about the
Right, we like drop the radical because it's 0. We have no plus or minus. How many answers did I get for these? For these up here? 2, and I only got 1 answer for this. Do you know what that means? What does that mean for the graph? It only has one x-intercept. That is the vertex. Yep, that's what it means, is that's the vertex. Okay? So that one just has one. Next one. Is it ready to go? No. Negative x squared plus 4x minus 13 equals 0. X equals opposite b plus or minus square root 4 squared minus 4a, which is negative 1, c, which is negative 13, all over 2 times negative 1. What? Are you thinking about factoring right now? We're not factoring. We're literally taking the 3 numbers, the a, the b, and the c, and plugging them into a formula. Okay? So if you were going to do factoring, yeah, you'd probably want to pull out that negative 1, but I'm not doing that. Okay? Also, there is something better that I would do for this if I did it on my own, but I'm not going to tell you until after we do this one. So. Well, I didn't have a decimal on the others.
Fraction counts as a decimal.
Okay. So maybe we will have decimals, but you're not going to see it written as a decimal. You're going to see it written as a fraction or a radical. Huh? Sort of, yes, but I want it there for this example, people. Okay. So we got 16. We're going to subtract. I don't know what that is. We're subtracting 52, so we got 16 minus 52, negative 36. Okay, so this is where I am so far. What should I do now? 3 questions. The first question is, let's simplify the square root. Because I know the square root of 36 simplifies. What about the square root of negative 36?
It will be 6i.
6i. So now we're going to have x equals negative 4 plus or minus 6i over negative 2. The second question, is there a number we can factor out of the top and the bottom that we could cancel?
No, not 4. Negative 2 with 2. Just 2. Yeah, 2.
Okay. I'm going to factor out 2. We could have factored out negative 2, but I want it there so I can show you the third question and what you would do. Okay? But I'm going to factor out 2, even though you could factor out negative 2. I'm going to factor out 2. So when I have x equals, if I take out 2, I have 2 parenthesis negative 2 plus or minus 2 divided, 3i over, then I have 2 multiplied by negative 1. So those 2's will cancel. And now I have negative 2 plus or minus 3i divided by negative 1. So we go to the third question. Is the denominator positive? Okay, it needs to be. So what you do when you have a negative number as the denominator, you take your magic pen or whatever it is, and you multiply by the number 1. However, the number 1 is wearing a disguise.
I.
No. That's I. That's not 1. But it is, no. I'll show you its Halloween costume in just one moment. I'm just saying, I'm literally multiplying by 1. You're only allowed to multiply by 1. but I put a disguise on this 1. Is -1 divided by -1, 1?
Yes.
Okay, it just has, it's disguised. So on top, I have to distribute that. On the bottom, we just multiply it together. I don't know what you mean by simplify.
The -1 over -1,
Yes, but I am not treating it as +1. I'm treating it as 2 separate pieces that are a negative divided by a negative, which is 1. But this allows me to change the appearance of this part over here. Martin?
So that means that I would be taken out.
No. Nope. It's a -1. It has nothing to do with I. It's just a -1. Okay, hold on. Let me just write it out and then ask your questions. So when I do -2 times -1, I get +2. I also have to distribute to the plus and minus 3i. So if I distribute to the positive 3i, I get -3i. If I distribute to the negative 3i, I get positive 3i. So these signs switch. And because I know that I still have a positive and a negative, they switch. Because I know I still have a positive and negative, I still write plus minus. They just switched.
Did you write like minus plus or?
No, we don't write minus plus. We write positive and negative. Okay, and then the bottom, -1 times -1 is +1, which I don't need there anymore because it's +1. So my answers for this are 2 plus or minus 3i. So where you guys asked me to take out the -2 instead of taking out the 2 here, that would be one way that you would have gotten the denominator positive earlier. It's up to you. Also, instead of moving the 13 this direction, if you notice this first term was negative, you could move the x squared and the 4x to the other side, and we would never have had to do that step. So you can manipulate around doing that step. But if you don't, and you have a negative down there, you have to get rid of it. Okay? Why don't you choose one of these 3? I totally I didn't write far enough over at the beginning, and I have all this. I don't have any space to write. I did the first one. If you tried the first one, that one's done. If you're trying the second one, I'm doing it right now. If you're trying a third one, you're going to have to wait longer. I might just use my calculator for some of this because I ran out of space to show all the steps. Uh-huh. What's wrong? Because I could make mistakes. What do you think? Never mind. Uh-huh. Hmm?
You're gonna put minus
4 times 41 is what? 164, yeah. But you have to do 64 minus 164, which is negative 100. Because that's the formula. I can't hear what you're saying, but I hear you saying you have a question.
Yeah, so for number 5, I did mine to be a negative n over 6. Right? Oh, you can like keep going further.
Oh, yeah, you can go further. I don't know why I didn't even notice that. You're right. So I needed to divide by 3 still, so I have negative 5 over 3. So your 10 over 6 goes further. What? Well, I could have started dividing by 6, yeah. I just didn't see it.
So do you still need the fancy brackets even if it's like...
You don't need the fancy brackets if it's just one. I just do them so that people don't forget them. Okay, so I have my 3 answers. I got negative 4 plus or minus 5i. I got negative 5/3. And then I got over here 1 plus or minus 3i radical 3 all over 7. Uh-huh.
You don't have to like divide it out? Like,
What do you mean by divide it out?
so the 7 is just...
Oh, underneath? You could write it, well, I don't have space, but you could write it as, I'll just try to make it as big as I can, 1/7 plus or minus 3i radical 3 over 7. So you could distribute the 7 by division. You could distribute that 7. So you could write it this way as well. I just, this one's more work to write, so I don't write it that way, but you can. And sometimes if you check answers somewhere for whatever, it might be written this way. Okay? We've got one last concept to go over from this section, and it's called analyzing the discriminant. So analyzing the discriminant is a fancy word that just means b squared minus 4ac. That's the discriminant. And we've already started analyzing the discriminant while we did examples. We actually already started analyzing the discriminant. I just didn't tell you that's what we were doing. So what happens when you look at b squared minus 4ac before you even finish this whole quadratic formula is this b squared minus 4ac tells you how many solutions and what kind they will be. This tells you the number of solutions and what kind. So down here there's a chart that says if we do b squared minus 4ac and it is greater than 0, that means it is positive. You will have 2 real solutions. If it is equal to 0, so we were talking about why did we only have one answer. on that one question that was like 2/5 or something. It's because the discriminant equaled 0, and that means one real solution. If the discriminant is negative, if b squared minus 4ac is less than 0, then we will have two imaginary solutions. So the graph will show that there's no x-intercept, but you can find the solutions with i's in them. So for these examples, we're just going to find the discriminant and then say what kind of solutions we'll have. So we're just going to do b squared minus 4ac. Do you notice how there's no square root involved? Just b squared minus 4ac. So I'm going to have 36 negative, let me try that again. I'm going to have negative 6 squared minus 4 times 1 times 10. So that's going to give me 36 minus 40, which is going to give me negative 4. So we're analyzing the discriminant. The discriminant is negative 4.
So we're using the discriminant to solve it.
We're not using this discriminant to solve it. We're using the discriminant to say, how many solutions will there be?
How many discriminants?
No, this is the discriminant. If it is negative, how many solutions will there be? Two imaginary solutions. So see how it has two blanks here? Two imaginary solutions.
Ooh.
So the next one, we're going to do b squared minus 4ac, and we're going to find our discriminant. So negative 6 squared minus 4 times 1 times 9. You see how this was almost the exact same question, only this one was 10 and this one was 9? So now I have 36 minus 36. What is our discriminant? 0. So how many and what kind of solutions do we have? We have one real solution. It's like, I was emphasizing that it was a 1. Okay, the last one, she's not. b squared minus 4ac. We're going to have negative 6 squared minus 4 times 1 times 8. So I have 36, take away 32, which is 4. The discriminant is 4. What does that tell me? Two real solutions. Right. And I just changed each equation by one number, and it gave you 3 different possibilities. I don't think we need to. Do we need to go over those again? Do you need to practice any of those? Okay, then I want you to look at the next thing. Find a possible pair of integer values for a and c so that the equation has one solution. One real solution. Then write the equation. So you got to think, b squared minus 4ac, if it has one solution, what's it going to equal? 0. Now we do know the b value. So if I do negative 4 squared minus 4ac, I need it to say equals 0. Without consulting anybody else, you're going to come up with what you think a and c could be. Without yelling it out, you're going to come up with those. Max, what'd you come up with? What is negative 4?
I got plus or minus.
Hold on. Max, what is negative 4 squared?
Plus or minus.
So Max, what's negative 4 times negative 4? 16. So will 1 and 1 multiply by negative 4? So what could A and C be instead? Which one's which? A is 1? Is that what you said?
Negative 4.
Wait, wouldn't C be negative 4 though?
Yeah,
Yeah, it would be negative 4.
Oh, well, no, it'd be positive 4.
What's negative 4 squared?
I got 16.
Positive, and then it would be 16 plus 16.
So, Martin, if you made C negative 4, what would your A have to be? Have to be negative 1, Martin. Thanks.
Hey, look, I got plus or minus.
I don't even know who that was. Was that? Who was it? No, okay. What'd you get? What did you get?
I got it plus or minus negative 4.
I don't know how I can say A equals C equals two numbers at the same time.
My ratio.
Okay. So, what else would work? Because that's not the only numbers that work. Who had a different answer? 2? 2 and 2?
I put plus or minus because I couldn't plug in. I don't know. It's just when I squared negative 4, you feel me? I had negative 4, AC equals 16.
Okay, you had that. That wouldn't be right. You would have negative 4 AC equals negative 16. Oh, sorry. You'd have negative 4 AC equals negative 16 if you moved the 16 over to the other side.
And then now I got AC equals.
So you have to divide by negative 4.
Yep.
So we've got A times C has to equal positive 4. That's an excellent way of doing it, except positive negative 4 is not going to tell you much. I need to know what A is and C is. So we have 3 answers that work. I need another one that also works. Yeah, we're not going to use decimals, but yeah, totally, you can. I'll do it as fractions in a moment, but I want, like, off of this one, what's a different one we could do? Negative 2 would work. All right, Drake's going to show off. Give me a fraction. So if this one's a half, then C would have to be what? 8. Isn't half times 8 also 4? So yeah, you could do fractions.
Wait, how about 16 and 1/4?
These types.
1/4 and then C is 16?
Yeah.
Yep. So there's probably infinitely many ways you could do this. You're just going to get uglier and uglier ways. But these main ones would be what I would expect you guys to come up with. If you want to be clever, totally go for it. Just makes more work for me. Right here we have a concept summary, and this is you know what? I'll put it back up at the end because I'm just going to talk here. So this concept summary, methods for solving quadratic equations. This is all the methods that we had in this chapter. Graphing. You could use approximate solutions. If you were to graph it, you could use approximate solutions. Maybe you'll get accurate solutions if they actually hit the x-intercepts. But graphing, you're finding the x-intercepts. Using square roots, you can only use square roots when you have something squared equals a number, like ax squared equals c. That's the only time you could use square roots. Factoring, if it can be factored easily, factoring would be the method I would want to use. Complete the square would be simplest if the a value is 1 and b is easily divided by 2. If b is an even number, then complete the square is pretty easy. And then quadratic formula, that can be used for any quadratic equation. So any of the ones from above, I can use the quadratic formula every single time. So guess what? This is used a lot in math. Yes, Avni? Yeah. Well, that's like if I were to graph something and then it's like this. Like you could approximate your answers if you're looking at the graph. We can actually get it more accurate, which is still an approximation. If there were decimals, you could use your zeros on here, and then we're going to get an approximation decimal. It's not always an exact answer, right? There were some we had to round, so that's what it means. Okay, you're going to have a big ideas assignment.